Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, today we have an elastic collision. The main objective of today's experiment, we want to investigate collision between two particles, ball and this ballistic pendulum. We will fire this ball from spring gun and we will let this ball to hit and collide with this ballistic pendulum. We want to investigate if this collision is elastic or inelastic collision. To decide about collision, we need to find what is the momentum before the collision and what is the momentum after the collision, and we need also to check what is the kinetic energy before and the kinetic energy after. And we know that if the percent change in delta V is small, that means the momentum is conserved. The same thing in the kinetic energy. If the percent difference in delta K is small, it is conserved. If the percent difference in delta K is high, that means it is not conserved. The kinetic energy is not conserved. But as you see in this experiment today, if the two collides particle after the collision stick together and move as one object, that means the collision is completely or perfectly an elastic collision. To find the momentum, we know that the momentum before should equal the mass of the first object, which is the ball alone, because the second object will be at rest. That means the momentum initial will be the mass of this object multiplied by its velocity, and after the collision the momentum will be the mass of the small object and the capital object, which is ballistic pendulum, multiplied by the final velocity. The same thing for the kinetic energy will equal 1/2 the mass of the ball multiplied by the initial velocity squared, and the kinetic energy final will be the mass of the summation, half of the mass of the summation of the masses multiplied by the velocity final square. The only problem we have it here to start doing these analysis, how to find what is the initial velocity and what is the final velocity after the collision. Now in this part, the main objective is to find what is the initial velocity of the ball when we fire it in the experiment. We will use the kinematics to find the initial velocity of the ball. We will fire the ball by using spring gun, and it will make projectile motion, and it will start motion in the x direction with initial velocity vi. According what you learned in kinematics, you know that we have x direction and we have y direction. The component there we need to investigate and to find out what is the v initial in the x direction. This is my target, our target. And what is the v final? We know that there is no acceleration in the x direction. Initial and final will be the same, and the acceleration in the x direction will be 0. And the displacement in the x direction, we can experimentally find the displacement in the x direction by doing the experiment when we run the experiment, and we can easily find the range covered by the ball when we fire it. And the time here also unknown. We have two knowns here, this and this, which are not enough to solve the problem in this direction. Now let us check what we have there in the y direction. The v initial in the y direction is 0 because we will release it only with components in the x direction, and the v final in the y direction we don't know it, unknown, and the acceleration in the y direction will be g, which is 9.80, and the displacement in the y direction will be the value of h. Then experimentally we can measure this value, and we will call this value capital H. And the time here also is unknown, but we know that the time here in the x direction and in the y direction will be the same. We have 1, 2, 3 knowns there. That means we can use the laws in kinematics to find what is the time. Then we'll substitute the time in the x direction. Now the time here equal to what? We know that x here or y in this direction will equal v naught t plus 1/2 a multiplied by t squared. V naught t will be 0, and the acceleration in the y direction will be g, and the displacement in the y direction, will be the value of h, which can be measured by the experimental motion. Then we can conclude the time covered equal to 2 multiplied by h divided by the
gravitational acceleration, and by that we know the time here. Now we will use that time in the x direction. We know that also in the x direction, x equal v naught t plus 0 because there is no acceleration in that direction. That means our x here, which is experimentally can be specified and equal to r, equal to v naught multiplied by t, v naught multiplied by t, or let me go direct. Our initial velocity, our target, equal the displacement, which is r, divided by t. Instead of dividing by t, I will multiply it by the reciprocal of this one. Then this will be r. Instead of dividing, I will multiply it by the reciprocal of this one, which is g divided by 2h under the square root. And by that, we can measure the value of the initial velocity when we fire the ball. Now the value of the h will be only one reading because this will be the distance from the ground to the center of the ball when you fire it, and it will be with measurement with 4 significant figures. But we have to do 5 trials to measure the value of the r. We will measure the value of the r for the first time, second time, third time, till the fifth time, and accordingly we can find v initial 5 times from first value to the fifth value. By that we finish the part of the initial velocity, and now we have to move to the next part. Now the main objective in this part, in the second part, is to find what is the final velocity exactly after the collision. We know that what we have in here is the ball inserted inside the ballistic pendulum, and the whole system will move with final velocity v final. Let me call this case number 1. Then after that, the energy will be taken by the ball and the ballistic pendulum and convert completely from kinetic energy to potential energy, which raise the center of mass of this system to some small height h. This is the center of mass here, and this is the center of mass, and this will be the value of converting h, which relating to converting the kinetic energy to potential energy. And this h is connected with the value of theta maximum here. Now, our target is to find what is the v final. We know that in energies, all energies at case number 1 equal all energies at this case number 2. I will not call initial and final because we have it before. Now, all energies here is only kinetic energy, which equal 1/2 multiplied by the mass, with the mass of the ball is small m, and the mass of the ballistic pendulum is capital M, multiplied by v at this case number 1 is v final square, should equal all energies we have it here, which is only potential energy, small m plus capital M, multiplied by g multiplied by h. We can eliminate this with that. Then the final velocity will equal to 2 multiplied by g multiplied by h under square root. Then by using the conservation of energy law, we can find the value of v final, which equal to 2 multiplied by the acceleration multiplied by the value of this small h. Now, to find this small h from trigonometric, we know that if we have triangle like this will be the value of the hypotenuse, which is small Italy r, and this also will be the same arm, which is the arm of the ballistic pendulum. If this is the theta maximum, if we know that from the theta maximum from this triangle, if this is r, this will be the value here will be r cosine theta maximum, and this small value here is our target small h. Now, to find h experimentally H equal R minus R multiplied by cosine theta maximum, which means H equal R multiplied by 1 minus cosine theta maximum. Remember that our sensor measuring this theta maximum in radian. Either when you use the analysis, when you want to analyze it, you have to convert the calculator to be in degree, or use the Excel direct in Excel using the SI unit. When you ask Excel to measure cosine any angle, and you specify a cell as that angle, it will consider that cell as radian value. We will repeat this 5 times, which will give us 5 values. 5 values. We will repeat it 5 times. Trial 1, 2, 3, 4, 5, and it will give us value of theta maximum in radian 5 times. Accordingly, we can measure the value of H in meter. We will have 5 value. Then substitute in this equation. We will have 5 values for the final velocity. Now we can measure the value of the momentum, because initial and final, because we have velocity initial and final, and we can measure also the kinetic energy for this collision before and after. We will collect all these data on a table, and we will write before and after in one column, and we will put the value of the momentum, kilogram meter per second, and we'll put the values of the kinetic energies in joules. Now we will draw this by using the Excel. After finishing from this table, we will put the values which measured 5 times as number 1, and under number 2, we will put the values of a final analysis for momentum and for kinetic energy. Now we will select the whole table here with the header, and we will go to the Excel. We will insert chart, which represents this, and we will end with some graph like this in Excel. This will be the x-axis. As you know, first column will be the x-axis before and after, and the first y-axis will be the momentum, and the second y-axis will be the kinetic energy. When we select this table, the Excel will give us 5 points. It will appear as 1 point here for the momentum, for the kinetic energy, and 5 points will appear as 1 point here. That means the kinetic energy initial and the kinetic energy final has big difference. Drop down, that means the most of energy is lost there as sound and thermal energy, and that means the collision is perfectly or completely in that collision. About the momentum, you will find that the momentum before will be some value, and the momentum after will be close to that value most probably, and there is only a small loss in that value because the error in the experimental error in our work. You have to consider the value of G in this experimental work to be 9.80 meter per second square, and this will be the constraint which will lead for the number of significant figures to report your analysis for momentum, kinetic energy, and all these things. Thank you.